Biomedical engineering is a subcategory of bioengineering, which focuses on the broadest spectrum of the biological applications of engineering in more areas such as agriculture, pharmaceuticals, natural resources, and foodstuffs. While the two terms are often used synonymously, biomedical engineering primarily applies the skills and principles from biology and engineering in the healthcare industry. As well, in biomedical engineering, practices from mechanical engineering, electrical engineering, chemical engineering, general chemistry, material science, general engineering, mathematics, and computer science are utilized to improve the health of the human through biotechnological creations such as the prosthetic limbs. Practice of biomedical engineering became more prominent after World War II, whereas before, the majority of biomedical engineering was led by doctors and physicians themselves. However, creations of biomedical engineering can be seen throughout history, such as through the invention of crutches or the more notable invention, the stethoscope. The stethoscope was created by the French doctor René
Laennec
to avoid putting his ear on a female patient's chest to hear her heartbeat. Through this minor inconvenience, he created the first iteration of the stethoscope by rolling up a paper tube and using it as a funnel. With this biomedical invention, he discovered that it actually amplified the sounds of the heartbeat, later on going to improve on this design to the one that looked like this one. Eventually, through this minor inconvenience, we developed the modern-day stethoscope. The introduction of computers was an important factor in the advancement of biomedical engineering. With computers, biomedical engineers were able to decrease the time it took to analyze data, which made the process of evaluating patients easier. The creation of the internet also allowed easier communication between doctors and physicians to discover medical correlations and patterns. These two inventions were well allowed for greater possibilities, such as the invention of the MRI and CT scans in the 1970s. Nowadays, with the intensifying impetus of the technological innovations, modern-day biomedical engineers look towards finding ways to improve the efficiency and low-risk processes in the medical field. Though one of the major issues that they face in their research is biological modeling. Biomedical engineers struggle with finding out how to create simulations in the body without harming the human involved, so that they work towards creating realistic and reliable simulations to run experiments on rather than using a real person, which opens up possibilities that were once limited because of the potential harm of the real person. An example of biomedical engineering can be seen in a CNN health article about a man who lived 555 days without his heart. The article states that in 2014 his heart was removed after discovering he has a genetic form of heart disease called familial
cardiomyopathy,
which is a condition that basically inhibits the heart to pump blood efficiently. As well, due to issues of finding a suitable donor, it was replaced with an artificial heart that was powered by the contents inside this bag. It was only after, as the article states, 555 days of living with an artificial heart that he was able to find a suitable donor for his condition.